All right, so we're getting into a kind of something that we've seen before, and with respect to the way the lesson is going to be presented. If you recall back to the math lesson, we went through a whole bunch of different functionality that existed inside the math library, math.pow, math.square root, and all those different ones. Now that library is super powerful for dealing with numbers. The thing is, we don't always just deal with numbers. We also deal with strings a lot. And a lot of data manipulation usually involves strings. When we get into big data, when you're working with databases and things like that, where you're parsing apart or breaking apart all the different information, a lot of times it's strings. It's not necessarily numbers. So what we're going to go through in the next couple lessons is how we can work with that data in an effective way. So the topic that we're going to be working on is something called string manipulation. And obviously, we're manipulating the idea of a string. So let's get into this. Now what you're going to see is a number of different things here, and it's going to work similar to the lesson with respect to the math lesson with respect to how you're going to see things demonstrated, a whole bunch of functionality, and then an example of that. So let's get into this. First of all, we have to remember what are the two aspects of actually manipulating strings. There's two things. We can inspect a string for certain traits, and we can modify the string itself into something new. And that's the key here. It's not actually modifying the original variable. It's actually modifying it's modifying a copy of that data. So what happens is whenever we change it in some way, we're actually not touching the original data. So we're going to end up with two variables instead of just one. The original one is left alone. The new one is a manipulated copy of that original one. And that's very important to keep in mind as we go forward. So I've posted a whole bunch of examples for you guys to follow along with. You can click on that little link there, and you're going to see how we work with this. Now, before we get into this, you need to remember how strings are actually stored in Java. Well, first of all, hopefully you remember the example we talked about when we discussed the happy birthday sign. It was a while ago now. But basically, remember that happy birthday sign and how it's strung together. You have each individual character that's attached by one long string. And that's where the term string comes from. So it's a string of individual characters that make up a word or a phrase. And that's what we're looking at. So remember, each one of these characters has an address. So the secondary term that we use for that address is something called an index. It's just where it's located within the string. And we number these letters from left to right, starting at 0. You might think, why do we start at 0? It's just what we do. Most languages are 0-based, which means when they start counting things like this, they typically start at index 0. So this is what it would look like. If we have the word hello world in a string variable, we have this whole thing, and each letter has its own address. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I were to ask you how many characters are in that string, you're going to tell me 12. Not 11, 12. Because it's the quantity of characters. Right? So again, it goes back to that happy birthday sign. But just like the real happy birthday sign, we can't actually change the string. They're attached by that physical string. We can't manipulate that. So that's why when we go to actually modify our string, we're not modifying that string. We're actually modifying a copy of the data. We're basically building something new out of what originally existed, that is. So, as I said, when we speak of manipulating a string, in truth, we're actually not changing the original string at all. We're making a brand new one. So that means that it's up to you, it's up to me, it's up to whoever's doing this to create a secondary variable to store that original string, or to store that new string. Now, of course, what if you want to actually make that change and make it permanent in the original variable? Well, you can do that. It'd be the same thing as if I had an integer variable, let's say it's called num, and I want to add 1 to that variable. Well, I would just say num is equal to num plus 1. Well, the math occurs, so whatever the value of num is, we add 1 to it, but then we store it back in the variable. That means that num has actually been changed. We can do the same thing with our string manipulation. We can choose to store it in a brand new variable, leaving the original data alone and unharmed, or we can store it back in the original variable, which would overwrite that data, which means it's gone. We have brand new data in there. So let's get into this. So for each one of these explanations, you are going to see a whole bunch of examples, and each one is going to use the following data. So I have three variables here: string word, which has the value hello world; string phone number, which has the value 555-123-4567. This is your standard Canada-wide format, with the exception of Quebec. And string new word, and this is going to be used to hold our manipulated strings. But I'm going to show you that we can store it in both new word or write back into word if we want to overwrite the data. So let's start by looking at the first set of inspection operations. So again, inspection operations are all about looking at the data and analyzing the data, not actually changing the data. Pardon me. So we can inspect a string and look for certain traits, for example, the length. Okay. What does this first command do? Well, this first one says, give me one of the characters. Char at. Char is short for character. Basically what we're saying here is, give us the current character at that supplied index. So remember, our words are separated by different addresses or indexes. So how do we actually find that? So in the example here, remember word has the value hello world. We're saying, give us the current character at index 6. Not the sixth character, the character at index 6. So we start counting. 0, 1, 2, 3, 4, 5, 6. It's the capital W, which is why that is what will get displayed on the screen. That's all that command does, char at. So the name of your variable, dot, char at. Most of these methods are going to work the same way. It's going to be the name of our variable, dot, and then the name of the method. Okay, that one's a pretty easy one. So we can see this in the actual code. Here, it's the very first thing that I did. We're going to demonstrate all these things, and if I run this code right now, we can actually see it pop up here, character W. It's the first thing that comes. Now, I'm obviously not going to write this code here, otherwise this video would take forever. So I've pre-written it, and we're just going to go through it as we go along. So that's our first one, and that's one of the most straightforward one. The next thing that you're going to want to do, and this is going to be a very common operation, is to figure out, well, how big is your string? Well, you might be like, well, I'm the one that wrote it there. Why wouldn't I know how long it is? Right? So if you have word, you know how long hello world exclamation mark is. You can just count the letters. But what if you didn't write it in there? What if you got the phrase, what if you got the value of word from the user? Then you have no idea. You don't know what the user typed in. You have no clue. So sometimes it may be important to understand that number. So we just call the command length. So whatever the name of our variable is, dot length. So here we have word dot length, and that is the quantity of characters. In this case, it's going to be 12. All right. So that's a pretty straightforward one. Next one is contains. This is a true-false check. Basically, we're saying, does the string text B exist in the string text A? True or false? That's it. So here we see it used, word.contains LO. So that means it's going to look in the word variable up here for the text LO. And if it finds it, it's going to give a true. If it doesn't find it, it's going to give a false. And it's going to start looking from left to right. So it's going to say, are you LO? Are you LO? Are you LO? Are you LO? Oh, there we are. Yep. Done. Return a true. That's it. So let's go take a look over here. We did this example down here. If we run it, we see we got our length 12 and contains low. Yeah, it does contain low. Of course it does. It's part of hello. So those are our three easiest commands. But of course we got lots more. So the next one doesn't just look for a string inside of another string. That's what contains does. What index of does is it says, where is it located inside of that string? That is a much more useful piece of information. Not just whether it exists, but where can it be found? So it says, find me the location, the index, of text B inside of text A. And again, it starts looking from left to right. So if we look at this, word.index of or. We look at this. Are you or? No. Oh, there we are. We got it. So it starts counting 0, 1, 2, 3, 4, 5, 6, 7. So that's going to give us back the value 7, not 7, 8, just 7. So it just wants the first character. But what if the character, or what if the phrase, or whatever text B is, what if it doesn't exist inside of the variable? Well, it's got to give something back. Remember, the whole point here is it's giving us back an index within Word. Well, if it can't find it, for example, if we're looking for little w doesn't exist in here. So what it gives back is a -1. And the reason why it gives back a -1 is because this is an impossible index. All of our index values are numbered from 0 up. -1 is an absolutely impossible index to have. So what that does is it tells us as programmers that later on we can check to say, well, if that number is -1, it didn't find it. This could be pretty useful. Now, for some of these operations, I have this little link here. If you click on this, it'll give you more versions of this operation. So for example, index of says, look from the first character for text B. So it keeps looking over. There's another version of this where you can tell it to start looking at a different character. Instead of starting at index 0, you can tell it to start looking at index 5 if you wanted, or 7, or 2, anything you want. So you can check out this link here and it'll take you to more versions of index of. A few of these are going to have that. So this is a great little tool to figure out where the first index of some text is. Now sometimes though we want to find the last index of, in which case we can use the function method last index of. And it does the exact same thing. But the difference is, in this case, it keeps looking until it finds the last possible scenario. Okay? In reality, what it really does is it looks from right to left as opposed from left to right. So that way it knows it finds it at the end. So in this case, in this example, I'm saying find me the last index of L. Now if we look at our Word variable, there's actually 3 L's in there. So if we used index of on L, it would have given us 0, 1, 2. But last index of is going to give us 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So depending on what your goal is, that may be a better operation for you. Again, we can go back to the example so you can see these things. So we have index of both of them, and then we have last index of. We can see that it's finding all these operations. Great, no problem with that. Okay, we're almost done actually. So the last set of inspection operations we're going to look at are the first one is. I didn't mean to show both, pardon me, is dot equals. Now, sometimes we may want to know whether a piece of text exactly matches another piece of text. Now later on, actually I guess at this point you've already covered selection statements. Now in selection statements, you saw the equals equals operator, and you said if num1 is equal num2. And we were checking to see whether the two numbers matched, or the two numbers matched. That's great. And that works for numbers. However, in terms of strings, we can't do that. String is a very special thing. It's not like a primitive type. If you remember all of the variable types you've learned in this course so far, int, boolean, double, all these things, if you've noticed that they're all spelt with a lowercase letter, int, little int, double, little double. But string is spelled with a capital S. And this is why. The reason is that string is actually an object. Now remember, we talked about objects before. Objects are things that have attributes and behaviors, data and functionality. Well, ints and doubles, they don't have that. But strings do, which is why we have all these commands like .length and .index of. Those are behaviors of the string object. Now, why does this matter? Well, it matters because when you try and compare two strings, it's different than comparing two numbers. So strings are objects. All of the other data types we learned are called primitives, primitive data types. And those ones are just values. They're just containers that store values. So when we compare them, we're comparing value to value. Is num1 equal to num2? Is the value equal to the other number? Is the value equal to the value? But with strings, it doesn't work like that when we use equals equals. What it actually does is it actually checks to see whether they're the same object. So if you have two variables that are pointing to the same location in memory, it does happen. You can do that. But that's not very useful when we're trying to compare two values. So in order to get around this, when we want to compare two strings, we use the method .equals. So in here I'm saying, is word dot equals phone number. Does word exactly equal the text of phone number? Of course it does not. Hello world and 555-123-456-7. So we would get the value of false as a result, which makes sense. So dot equals is in the place of equals equals when it comes to strings. Okay. Last one for inspection operations. Ends with. All this one does is basically it's a true-false check to say, does the text that I'm testing end with this text? So look at this. In this example, I'm saying, does word end with 67? Well, oh, that should be phone number. Ha ha, that is type O. I actually don't want that. I want that to be phone number. We're going to fix that right now. There we go. Yes, phone number does end in 67. And it ends in exactly 67, which gives us back a true. Sorry about that. There we go. So those are all of our inspection operations. Let's go back over to our code for a second and take a look at these in actual action. I've put detailed comments here. Normally I wouldn't comment it so thoroughly or anything like that, but this is just an example so you can actually see everything. Now if I left my mistake in here and I actually kept this as word, I would have word.ends with 67. We run it. We're going to get a false because word is hello world and it of course does not end in 67. And that doesn't make any sense to try and do that. So those are all of our inspection operations, things that just look at the values but do not change them. In the next lesson, we're going to start manipulating and modifying all of this data.